Okay, we're going to talk about our last method, which is the quadratic formula. The nice thing about the quadratic formula is it works all the time, every time. You can't always factor everything. When you graph, sometimes you get those fractions that you can't really tell what they are. When you are square rooting, sometimes you need to change it into completing the square. And for completing the square, that middle term has to be an even number because I have to divide by 2. You can do it with fractions, but if you're no good at fractions, it's a big pain in the butt. The quadratic formula is the only consistent one that works. And the quadratic formula is probably my least favorite because if you're not really good at order of operations, or you're not really good at working with negative numbers, there's a lot of steps you have to do, and if you rush through those, it's too easy to make a mistake and you have no idea where you made that mistake. So it's probably one of my least favorites just because of that. It's very tedious, it's very detail-oriented, but it's nice because it's consistent all the time. So the quadratic formula works with the quadratic equation, where we have an a x squared plus bx plus c equals 0. And so knowing these a, b, and c values, which we've done before when we graphed, we can plug in those values into this quadratic formula. And you do have to have this memorized for your test. And a lot of people do well when you attach things to music. So we have Pop Goes the Weasel. And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so just using something like that really helps it when you're trying to memorize. So we're going to go ahead and move to our first problem, when we're going to identify our a value, which is 6, our b value, which is 5, and our c value, which is negative 4. And we're going to plug those into our quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times our a times our c. Now the whole thing is over 2a. And the biggest mistake people make is they only put the 2a under part of it, and they don't save that dividing for the very last step. That dividing should always be your very last step when you're calculating the quadratic formula. So now we're going to go ahead and simplify this. So this is going to be negative 5 plus or minus the square root of 25 minus, and now we're going to go ahead and times on our calculator, 4 times 6 times negative 4, which is negative 96. And this is where people mess up a lot too, is they mess up on their negatives here and they don't realize that the minus and negative turns into plus. And so now we're at this point. And so now we're going to go ahead and add 25 to 96, which is 121. So now we get an answer of x equals negative 5 plus or minus the square root of 121 over 12. Now we can actually calculate the square root of 121. And so the square root of 121 is 11. So now we're at 5 plus or minus 11 over 12. And so now we deal with this plus or minus part. Here we go, plus or minus part. Which means that I'm actually breaking this up into 2 different answers. The first one is going to be 5 plus 11 divided by 12. So 16 divided by 12, they can both be divided by 4, which gives me 4/3. There's one of my answers. And then I can also do the minus part. 5 minus 11 divided by 12, which is negative 6 over 12. They can both be divided by 6, which gives us negative 1/2. So now I have my 2 answers. X is 4/3, and it's also negative 1/2. And there's our answer. So the nice thing about the quadratic formula, works every time, and it's the same thing over and over and over. So once you get the hang of the process, you're fine. Just have to be careful about your negatives and doing your order of operations correctly. So let's try another one. So our next one, it doesn't have an equal to 0. So we need to make it look equal to 0. So we're going to move this 20 to this side, which means now it's going to look like x squared, and I'm going to write 1x squared minus 1x minus 20 equals 0. Has to be equal to 0 for this to work. So then we get an a value of 1, a b value of -1, and a c value of -20. So now we're going to go ahead, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Whew. A lot of work, a lot of writing. But again, it's consistent. It's the same thing over and over. So negative negative turns into positive 1, plus or minus the square root. -1 squared is 1, and minus 4 times 1 times -20. 4 times 1 times -20 is -80. Luckily, the double negatives cancel each other out, so that's now plus. That's a plus. And this is 2 on the bottom. So now this becomes x equals 1 plus or minus the square root of 81 over 2. The square root of 81 is 9. So 1 plus or minus 9 over 2. And now we're going to deal with the plus or minus. So I have a 1 plus 9 divided by 2. Or 10 divided by 2. Yay, no fractions, it's just 5. And then I have 1 minus 9 divided by 2, so -8 divided by 2. Yes, it divides out, no fractions. And so now I have my two answers, x equals 5, and it equals -4. So now we'll move on to the next problem. So here our a value is -3, our b value equals 5, our c value equals 2. So now we'll plug it in. X equals -b plus or minus the square root of b squared minus 4 times a times c, whole thing over 2a. So this is going to become -5 plus or minus the square root of 25 minus, let's go ahead and multiply, and we get -24. Negatives cancel out, whole thing over -6. So this becomes -5 plus or minus the square root of 49 all over -6. Square root of 49 is 7. So x equals -5 plus or minus 7 over -6. Then we split up. -5 plus 7 over 6. -5 minus 7 over 6. So this is going to be 2 over 6, which reduces to 1/3. And this is going to be -12 over 6. -6, ooh, that's a -1/3. Almost messed up. And this is going to be a +2. So now we have our x values, -1/3 and +2. So we've seen positive and negative answers. We've seen positive answers, negative answers. We've seen fractions. We've seen whole numbers. It gives it to us, all of it. Okay, so now we're going to talk about many quadratic equations cannot be solved by the factoring graphing again, but the quadratic formula always works. So again, showing you how these won't work by any other method, because you could probably look at some of the others and could have factored them and solved them. But these ones won't work by the other methods. So here, a equals 1, b equals 3, c equals 7. We plug it in. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So it becomes -3 plus or minus the square root of 9 minus 28 all over 2. So I get -3 plus or minus the square root of -19 all over 2. And now I notice that I can't square root a negative, which means that this is no solution. And I know for sure that it's no solution. There's no, oh, I can't factor it, so there's no solution. It's a, I know that there's no solution. It's not a decimal, it's not a fraction, it's not something I couldn't come up with. There is no solution because I cannot square root a negative number. And then why would this method not have worked with completing the square? 3 divided by 2. It's going to give you a fraction, and fractions are hard to work with when you have to add and subtract and all of that. Okay, so next one, a equals 2, b equals -8, c equals 1. So our x value is going to be -8 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So this is going to become +8 plus or minus the square root of 64 minus 8 over 4. So we get 8 plus or minus the square root of 76 over 4. And again, not a beautiful perfect square, but we can calculate it on a calculator. Square root of 76 is 8.717797887, which we're just going to round to 8.7. So this becomes 8 plus or minus 8.7 divided by 4. So it's 8 plus 8.7 divided by 4 and 8 minus 8.7 divided by 4, which gives me 16.7 divided by 4 and -0.7 divided by 4. And I can't have a decimal inside of a fraction, so I'm going to have to divide that out. So 16.7 divided by 4 gives me 4.175. Whoops! Almost dropped my calculator, which gives me an answer of really 4.2. And then -0.7 divided by 4 gives me -0.175, which is really like -0.2. Now usually we want you to use longer decimals because it's more exact, but at this point in time we're not using it to build important stuff, so we're not too worried about longer decimals. But if you're actually using this to build stuff and all that, you want to use longer decimals because they're more exact.